Ma'am, if you allow, can we start?
Hello, Shelly.
Hello, Dr. Praneeth. Sakshi.
Professor at JP Institute of Information Technology, Noida. I welcome you all on the 5th day of the FDP. I'm excited to get this opportunity to introduce our first speaker of this morning, Dr. Shelly Sachdeva. Dr. Shelly received the BE Honours and MTech Honours degree in Computer Science in India in 2001 and 2004 respectively. She received the PhD degree in Computer Science in 2012 from University of Aizu, Japan. She is currently working as Associate Professor and Dean, Student Welfare with National Institute of Technology, NIT Delhi, India. She is having more than 18 years of experience in the area of teaching and research. Her main research are in the area of database systems, the high-level query interfaces, security in databases, computational intelligence, interoperable electronic health records, and data quality for health informatics. She received Japanese MEXT scholarship from April 2009 to March 2012. She was awarded Gold Medal for Masters of Technology in Computer Science in 2004. She achieved Indian Government Scholarship for Master's Program in 2002. She qualified Graduate Aptitude Test in Engineering in 2002. She attended many conferences, workshops, and presented poster papers. She organized workshops, faculty development programs, and currently coordinator of master program at JIIT. She is reviewer and member of several transaction and international conferences, including IEEE. She aims to mount women in engineering. She is member of Association of Computer, Electronics, and Electrical Engineer, CSTA, and Open EHR organization. She has published more than 80 articles in reputed referred journal and conferences. On a final note, she is also a fascinating individual, and we are grateful for her presence among us today. Without any further delay, I welcome Dr. Shelly and request her to enlighten us with her knowledge. Shelly ma'am, please.
Thank you so much, Sakshi. I hope my slides are visible, Sakshi, on the slideshow mode.
Yes,
slideshow mode. Okay. Okay, so we'll start today with the blockchain and its application. As per being informed by Dr. Raghu that you already, all the participants, very good morning first of all to all of you. And as per informed by Dr. Raghu that you have already done the various topics related to the blockchain, although I'll give a glance of all those topics, just a revision of that, and then further I'll move on to the blockchain and its corresponding applications. So I'll be giving you a very brief introduction with some really motivating examples and the real life examples that you are seeing nowadays around the world. And then I'll focus upon how we are moving towards the blockchain applications. I'll talk about some certain research directions from various perspectives, and finally I'll conclude my talk. So this is the evolution of the information transfer, as all of you are aware of, that where would you go to learn about a cardiovascular disease? So in the earlier days, what you were doing is you were looking for an encyclopedia, and that is how, or you will be going to your library and search for the page that you was requiring. So nowadays, eventually and gradually, we shifted on to something called as a Wikipedia. So we usually turn on our phone, we search for that particular piece of an information, and our answer is there with the Wikipedia. So this is how the information transfer is taking place from a centralized point of view towards a decentralized point of view. So the idea and the aim to show this particular figure, or to give this particular example, is that we are moving towards from the centralized thing towards the decentralized content. So this is what the blockchain involves. Blockchain says, despite of moving on from a centralized concept, let's move on to a decentralized concept. Now, this is the banking example. As all of you know, that what usually happens is, these are the traditional banking systems. We have some users, and we want to interoperate among one bank, for example, an ICICI, and another bank, for example, an HDFC. And we just want to interoperate. The users want to transfer money or do some particular transaction related to a banking sector. And that is what the traditional banking system is. And let us now consider a case where we would like to do an international wire transfer. Okay, so in doing an international wire transfer, we have something as an intermediary between these particular banks. That can be a PayPal, that can be a particular some correspondent bank or something like as an intermediary, right? So what happens is, usually in the earlier times, it was taking much time when you are transferring your particular amount, for example, from India to Japan. So this is usually costly, and this is usually slow also. So this correspondent bank is a slower one. So that is why what the new idea and the concept that the blockchain introduced is remove this particular correspondent, remove the intermediary. So this particular thing is that you remove this intermediary, you will be able to transfer from the sender towards the receiver. So that is what the blockchain network is. So blockchain network is a combination of nodes. Each node is carrying the same copy of the ledger, and it is having a peer-to-peer network. Okay, so this is just a simplified view. All of you have till particular day, that is, I guess, the day 4, right? So it started from the Monday, Tuesday, Wednesday, Thursday, Friday. Okay, so today's Friday, so it's a 5th day. So you might be aware of what this block is. Okay, so I'll not go into the detail, but I'll just let you know that what properties are there, so that I should be able to cater them in various applications I'll be discussing. So it's an immutable is the property. What it means is, mutability is that in related, try to just relate it to a database, where what particular thing we can do is, we can have a delete command, we can have an update command, we can have modify the data, and all things are possible. But what happens into this particular blockchain is, it's an immutable. So once you are writing onto this particular block, nobody is able to change that particular block, right? So it's a transparent. It means whatsoever is being written onto these particular transactions is transparent to everyone. Transparency in terms of that all the particular nodes that are participating into the blockchain have a transparency of seeing what particular transactions were being entered onto this particular block. Now, it's secure. It's anonymous means, for example, if I am transferring some money, right? So my name is Shelly, and I'm transferring some money to, for example, Sonia, right? And Sonia is having an account in. So my name is Shelly, it is being reflected, and the name is Sonia to whom I'm transferring is being. So what it says is that this particular blockchain concept says that your identity is anonymous. Nobody will be able to identify into the blockchain that Sonia, by the name of Sonia, did a transaction to, by the name of Shelly, did a transaction to Sonia. So it's an anonymous. My identity will be something like into the form of a key, which will be encrypted twice before being putting up at this particular place. Now it is integrity, so you can rely on it. You can say, okay, it is an whatsoever the data was being sent at this particular place is, you can see the property of the integrity if you are into this particular blockchain. Now, what do I mean by append only? Append only means that a particular block, for example, a block 3 can be appended, right? I cannot delete the block 1 and 2. So once block 1 and 2 are created, I can just append only this particular block 3, depending upon all the particular people in the that particular network have a common consensus, and they say 50%, more than 50% says, okay, this block can be added. So then only that particular block can be appended into that particular blockchain. So this is the general blockchain structure. So if you see, this is the hash, this is nonce, this is timestamp, Merkle tree root hash, and the various transactions starting from 1 till n. So that is what is there. Now, this is the example where the blockchain is being used nowadays. So most of us are making use of an application called as a blockchain and as a big basket, and some of us are making use of an application, for example, a smitten one. So see what big basket has introduced as a blockchain concept is this one. So I did some particular purchasing on a big basket, and then it says, okay, for this particular purchase, you have earned 2 new coin. So it's a kind of a currency, but that in actually is not in terms of a rupees or something, but it's a virtual currency, right? So this is where the concept started with when we started with the term called as a Bitcoin. Okay, so this is what it says. Okay, new coin is there, and then Smitten is another application which says, okay, you did some particular feedback for some particular product, and then you earned some particular points based on that. So, for example, it says that on every particular feedback or rating that you have done, you'll earn 5 Smitten bucks. So the Smitten bucks is another form of a currency. That's not in actual, not a physical kind of a currency, but yes, it's a virtual kind of a currency. So this is how most of the application nowadays are moving towards this particular cryptocurrency kind of a concept. Now, these are the 5 requirements of the hashing algorithm you might be aware of. One way, deterministic, the avalanche effect, collision free, and must withstand collision. These are some of the advantages and challenges which we'll be discussing while we'll be discussing various applications. So I'll focus upon, I've already told about the advantages, the traceability, the transparency, democratic, immutability, and the intermediary removal is there. So these are all considered as advantages. But while implementing this particular blockchain, what are the various challenges that we'll be facing? So the main challenge, what I'll consider from my viewpoint, is that throughput. So throughput is the challenge, then latency is another challenge, right? And consistency is the third one, then fog prevention and huge storage requirement. So if we have different particular users and there's one user called as a miner, right? So that particular miner, in order to mine that particular transactions and to say, okay, this is what the hash is being, this is what the key is being generated, requires a huge requirement of the resources at his or her end. So now this is just to show you from the particular graph that the blockchain size and the energy consumption, this is how it is rapidly increasing, right? So this is the blockchain size in gigabytes, and this is how it is increasing from till July 2022. And this is another related to the energy consumption, where we are showing that, okay, the blockchain is taking and this particular energy consumption is moving to this particular by January 2022. So now this is if we have a basic knowledge of a relational database, so I can simply compare and I can simply differentiate it in terms of a blockchain that, okay, what we have into a relational database, we have the database definition language and we have a database manipulation language. So what we can do is we can create table command, we can do we can read the data, we can write the data in terms of, you can have the corresponding syntax of that. You have a delete command, you have an update command. But blockchain says nothing like a delete or modify. Okay, so it's only append only distributed ledger. So this is the basic difference between the two. Then data can be deleted or altered. It says that no deleting or no editing of the recorded data. So that is why immutability is there. This, most of the times when we are talking about a relational DB, most of the times it says we are talking about a centralized DBMS, which we are going to teach to our students usually into the 3rd semester of our BTech curriculum. And then we have a course on a distributed databases also, so we can move on towards that one. But as far as the comparison of the database and the blockchain concept, it says the relational DB most of the times is working on a centralized concept and the blockchain is working on a decentralized concepts. Now there is one thing into the database that are called as stored procedures, and what those stored procedures are responsible for, they're responsible for the data validation, and also they are responsible or they have a functionality of providing an access control. So similarly, very similar to the concept of the stored procedures into the database, we have a concept of smart contracts onto the data, onto the blockchain. Now, these smart contracts are usually stored on the blockchain and they are executed automatically. And what are they? They are a set of rules that oversee the blockchain transaction, right? So this is how we can have something which is similar to a database and some things which are simply variable from the point of view of a database. Now, this is the blockchain autonomy and how the block is validated. So by now, I guess you might have a very good idea of how the block validations happen into a blockchain. This is the Bob, this is the Robert, the transaction is there from a Bob to a Robert. So this particular transaction needs to be added to the block, right? So before adding it to the block, it is broadcasted onto the network. and there are miners who usually try to solve a puzzle and to generate that particular hash. They may make use of different consensus protocols, and all of these have to follow some particular consensus protocol. Okay, so then after all the particular people, that's those who are taking participation into the blockchain network, will validate the block, and only it'll be added only to the blockchain when the consensus is more than 50%. So this is the blockchain autonomy. These are the features of the blockchain. Now, how should a person decide? I would like to have different sectors. For example, I have a healthcare sector, I have an IoT where I can make use of a blockchain. Then I have some e-voting kind of a sector. Then I have a finance sector. But how should I decide whether I should go for a blockchain or I should not go for a blockchain? So that is why, from the perspective of the marketplaces, the first question that particular should arise into that particular person's mind is whether I should make use of a database or I should make use of a blockchain. And if in case of I should make use of a blockchain, which particular kind of a blockchain? Whether I would like to have a private blockchain or whether I should move on to a public blockchain. So here we start with, would a traditional database meet your requirements? If it says yes, the traditional database meet my requirements, it provides me ample amount of security, it provides me ample amount of authentication, and it gives me all the access control mechanisms, plus it provides me everything what I need is, so it is never recommended to go for a blockchain. If the answer to your question is no, then does your database require share write access? And if the answer is no, your database doesn't require to have a share write access, then you should not go for a blockchain. If the answer is yes, then do all the participants trust each other? For example, if I'm doing a banking transaction, it means that I'm trusting the bank. And that is why I'm doing a transaction on a bank, right? So that is why I give the authority to the bank. Okay, this is what I would like to do as a transaction. So do all the participants trust each other? And if the answer is yes, then we have a separate block. And if the answer is no, then we should move on to this particular site. So if the answer is yes, is all the participants trust each other, is your database likely to be compromised or attacked? If I'm very much sure, okay, I've kept it on something as a centralized server and my server is very strong, and if so, I should not go for a blockchain. If it says that yes, I may compromise the security of my database and there is a possibility it might be attacked, so then should the data be private? Depending upon that, I should go for a private blockchain. And if in case, if the data is not to be a private, I still need to ask one question and then I'll move on to this one. So we were on to this particular no side, is the third party involved or required? And if the answer is if the third party is involved or required, right? For example, as an intermediary, which we had seen into the example of a bank, then it says yes. Okay, so blockchain is not being needed. And if the third party is not being involved or required, then do you need to control the access to the blockchain? Yes. If you need to control the access, you should move on to a private one. And if you don't need to control the access to a blockchain, you should go for a public blockchain. So this is how you can decide that whether to go for a blockchain or not. And then further, once you have decided to go for a blockchain, whether to move on to a private blockchain or to move on to a public blockchain. So now these are the types of the blockchain where we call it as a private and a public one. So these are, for example, the Hyperledger Fabric belongs to the category of a private one, and the Bitcoin belongs to the category of the public one. As I already told that they may make use of different consensus protocols. For example, when I'm talking about this particular one, it makes use of a Byzantine fault tolerant protocol. And when I'm talking about a Bitcoin, it may make use of a proof of a work protocol. So these are some of the applications that we'll be discussing. I'll be showing you some examples and some of the projects that are going on into different sectors. And for example, healthcare is one of the sector, government is another sector, finance is a sector, then land registry. So in a finance, for example, how can we use it into the form of a cryptocurrency and security tradings? I'll be discussing in detail one of the example of an e-voting and correspondingly how we can have a smart citizen by implementing a blockchain concept. Then in the land registry, then you might be aware and you might have heard of that the particular person is there, and that particular person usually used to do what? Used to do that particular person used to sell that particular land to one party, as well as that particular person used to sell the land to another party also. So if we have such kind of a concept such as a blockchain, right? So everything is transparent onto the blockchain. So the person X can also see it, the person Y can also see it. So there are very minimum possibility that that particular land which belongs or has been sold to one person, there are very much less chances of the other person being purchasing the same land. So that's what an advantage, where we have an example of a land registry. Then is the supply chain management. So in the supply chain management I'll be discussing one example related to, for example, we embed an RFID or some kind of a chip into, and we had some particular product, for example, and I want to send that product or an import and an export kind of a thing is happening, and that particular product wants to be delivered to the sender side or another country. So the supply chain management, the product traceability can be done easily through the blockchain. Then we have the use in the agriculture. I'll be talking about the challenges into each particular sector, that what challenges we will be encountering while we will be using the blockchain concept into these particular sectors. Then we can use the blockchain concept into a power industry also. So what are the advantages if I move on from simple one towards the blockchain? What are the challenges? Then IoT, we have some particular applications or use case scenario as a smart home, and also education also. So for example, education, I attended one webinar or a workshop was there, and then I received an encrypted certificate from their particular site, and they say that was a startup kind of a company, and then they offered, okay, the certificate is being provided, right, anonymously, but that particular person was being provided with a key, and on putting that particular key, I was able to see, okay, my name was there, and then I was being provided with a certificate for that particular webinar. But that was generated through a blockchain concept. So in an education sector also right now, we are making use of a blockchain. So before moving on to different applications, all of us are usually aware of the OSI models. I guess, Dr. Raghu, what is the background of the participants? Dr. Raghu, okay, so they might be aware of the OSI model and the particular layers about it. Okay, thank you so much. So everybody is aware of, so I'll start with the data layer. Okay, so whatsoever you have learned till date about the blockchain, you have learned about a data block, you've learned about the data chain structure, the timestamp, the Merkle tree, the digital signature, and the hash function. So all these things are usually to be placed under the data layer. Then comes the network layer. So we are trying to move from the centralized towards the decentralized concept. So we are making use of a peer-to-peer network. We have a communication mechanism, and we also have a verification mechanism. So all these comes under the network layer. Then we are talking about the consensus layer, where we have the proof of work, the proof of stake, right? And the other protocols are also there, where we usually focus upon, okay, what is the throughput, what is the latency, what will be the energy consumption, what will be the mass consumption, if we'll be making use of this particular consensus, and what if I move from this particular protocol towards another one. So this is where another research is being going on. Then incentive layer is there. So as I told you that the miners are usually working for earning the incentives, right? So but they really need a very good infrastructure at the particular end in order to mine that particular information. So the incentive layer can have the allocation mechanism is there, and the issuance mechanism is there, which comes under the incentive layer. Then is the contract layer. So under the contract layer, just as very similar to the stored procedures in the databases, we have the contract layer. So that contract layer can either have a script code, or it can have an algorithm mechanism, or intelligent contract can also be there. Then what I am talking to you, what you have learned in the previous days is you have learned about all these layers, right? And today what we are learning is at the application layer. So we are talking about a programmable currency. We are talking about something called as a programmable finance. We are talking about something called as a programmable society. where we are talking about smart homes, we are talking about smart voting, we are talking about smart citizen, right? So integrating blockchain with other particular application areas that are predominantly dominating the societies nowadays, all of them are considered an integration of whatsoever capabilities they have, and the concept of the blockchain makes them into the application layer. So that is why I just had shown you this particular diagram where we are talked about the blockchain layers. So these are some of the application scenarios where we have an application scenario. So sometimes we say that, okay, blockchain is going on and going on, but is it really useful nowadays? Or are there really some application scenarios which are working on? So yes. So Sweden is having real estate transactions. Estonia is having transparency into the medical records, right? So then Russia is also implementing, and secure trading between the stakeholders is possible in Russia. And then in the Ghana, we have temper-resistant property ownership in these ones. So these are some of the application scenarios that are there. And these are some of the blockchain projects which are currently running into various application areas. For example, into the financial field, we have these as the cryptocurrencies. We have the Bitcoin, Ethereum, Litecoin, Ripple, and EOS as the digital currency, and the projects are going on in these ones. Then we have the global payment project as Interledger and Libra. And then we have financial services project also related to the financial field, and where CRDA making use of Accorda is there. And then in an IoT, we have some certain particular projects that are running on. So chain of things is there. Then IoTA is another project, and Slocket is another project. In the supply chain management also, we have certain projects that are running. For example, the Trade Lens and the Everledger are some of the example to it. In the social welfare and the healthcare field, we have certain projects, and we have big some particular med chain, for example, is a particular proposal that has been proposed in the healthcare sector. Then blockchain architecture has been proposed, and patient tree INC is another project that is going on. MediLedger is one of that is going into an healthcare field, and in an education one, the Turing chain, and these are some of the projects that are going on. And in the government and the energy field, we have Enerchain and some of the energy web chain and LO3 energy as the projects that are going on. So if you would like to have the details, so whenever we would like to work in any of the sectors related to the blockchain, first of all, we should just explore and go to these particular projects. We should have a glance, the corresponding this particular comprehensive survey paper, which has the references to all of these projects. So first of all, if I want to go for a blockchain into an education field, or I want to go for a blockchain into a healthcare field, I should just have a glance at, okay, what are the existing projects? And what is the novelty for that particular project, and what are they lacking in? So correspondingly, I can either do a research based on that, or I can apply for a project into either a DRDU or DST or SERB corresponding to what my state of art is. So these are some of the use cases of applying the blockchain technology. So this is what I was referring to you as an example in the supply chain, where I was talking about, okay, I have to do an import-export kind of a business, and I have an RFID kit. So whatsoever is the reading, for example, at that particular place, that particular thing has been halted because of some particular reason. So that particular transaction goes on to the blockchain. So it's very transparent, and the business party, the one who has sent the product and another one who is the sender, both of them are onto the transaction, and they are aware of, okay, where the product has been stuck. Okay, so everything based on that particular IoT device that is being attached to that particular product, the data is being entered onto the blockchain. So blockchain is enabling the IoT devices to usually send the data, and that data is included into the transaction repository, and that too are tamper-resistant records. So now, अब आपको ये नहीं पता, अब आपको ये पता है, you are very much aware कि यहाँ पर stuck हुआ है, and if you query, you might be able to know the reason why it is being stuck. So earlier क्या था कि आपका कोई भी रोक लेता था, right? And that person wants some money from you, and that is why the person had stopped. Irrespective of any reasons, the person has stopped. Right, and then you should go to that particular office, you should bribe that particular person, and then only your import export kind of a thing will happen. But if you move on to a blockchain kind of a thing where you have the temper resistant records, right? So if you are doing it illegally, your things will not be hampered or tampered at that particular place. Now, this enables the business party to access and supply IoT data without the need for the central control and the management. And you can even optimize the supply chains. You can track the objects, right, as they are traversing for an export-import supply chain, and while you can also enforce the shipping and the expediting incremental payments, both from all the business parties, the sender one as well as the receiver one. Now, another application is, for example, a car micro insurance application. Okay, so right now, what is the usual scenario when we are going for insurances? We usually call that particular person, okay, this is what has happened, and then then we usually claim, and we usually have to buy it for the complete 1 year and so. So what this car micro insurance application says is something similar to a cloud, pay as per you go. Okay, so this is what it says, that pay as you go kind of an insurance. So that is why it's a car micro insurance, right? So all the parties that are particularly involved in this pay as per you go kind of an insurance, for example, the driver is one party, the insurance company is another one, and the financial institution is another one, right? So if they are moving towards a blockchain, the insurance contract that is being created between the driver, the insurance company, and the financial institution is tamper-proof and traceable, right? So what the benefits are? The benefits are that you can claim request regarding the trick very quickly and indisputably, because everything is very transparent, where the particular driver has met the accident, on which particular time, which particular date, and then why it happened, and then insurance company, because everything is being entered in as a transaction into a blockchain, right? So the insurance company is also aware of, and those are tamper proof, so you cannot edit it. I also cannot edit it, neither the driver nor the insurance company nor the financial institution, right? So there's a traceable also, because there is a transparency into the blockchain. You move on to that particular block, see the transaction that has happened, and then you will be able to give the whatsoever the insurance the particular person has claimed is easy for that particular person also, as well as for the company also. So then it says, okay, what happens is, now another thing is to relate this particular thing, that if I'm giving, whether the insurance company should give that particular pay as per you go kind of a thing. For example, there is one driver who has a very bad track record, right? So most of the times, if the vehicle is being given and that particular driver has met, for example, 10 or 12 accidents, and most of the times that is being recorded into that particular driver. So that is a kind of a risk, right? So that is a kind of a risk, but the micro insurance application moving towards the blockchain can even assure you of that, right? So what it says is, you have a database, right, where the past behavior of that particular driver and that particular vehicle has been recorded, but that is a separate database, right? And now the blockchain size is very much like a smaller one. You cannot keep so much of big data onto the blockchain, otherwise the blockchain will be very heavy. So there is a concept called as an on-chain and an off-chain data, right? So that particular concept was being proposed. I'm sorry, I forgot to mention the reference for that. But that particular on-chain and off-chain storage says, whatsoever is the data related to the past behavior of that particular driver, the data related to the vehicle, and the statistics related to that is being saved onto a different database that is usually kept off-chain, right? And the other things, for example, when the driver is traveling from position X towards position Y, that particular trip is being recorded and that is being kept onto the blockchain. So small transactions are there and small data is there, and that particular data is being kept onto the blockchain. Okay, so this is how a blockchain can also, a system architecture has been proposed which can make use of the bulky data to be kept onto the off-chain storage, and this kind of a data which requires to be very secure and tamper-proof is to be kept onto the on-chain. On-chain here refers to onto the blockchain, and then Then there is an interaction from an off-chain to an on-chain. So the system architecture proposes it, how to link that particular on-chain and off-chain data structure database, and then give the corresponding whatsoever is being required for that particular application. Now there is another example and a use case of an online voting system, since we are talking about different marketplaces. So I'll be giving you an example of an e-voting or an online voting system also. So you can see how the variation is when I'm talking about keeping it onto the simple one. What we are doing nowadays, we usually go to the toll booths, we usually vote we have a particular symbol at this particular place, and we usually then come back with that particular we go along with the voter ID card, and this is the normal process, right? So I'll show you in an example through the steps that how it has been changed and what are the advantages if we move on to e-voting systems. So first we'll discuss the first marketplace, that is the healthcare. So the major issues with the traditional systems are that they are very slow, right? So for example, the copies of the medical data must be prepared, delivered and picked up by the patients. Then the next one is it is insecure. The data copies may be lost at times, or they may at times may be stolen during the physical transmission whenever I'm moving from one location to another. Then they are incomplete, right? So the data is fragmented, so there's no single source of a data. You move on to one particular unit, you will get the data related to pharmacy. You move on to another unit where you will get your X-ray data, right? You move on to a third unit where you will have some other lab test data. So that's an incomplete, and the data is quite fragmented, and there's no single source of a data, and an integration is there where I can see, where I can say, okay, this is the single thing, right? Having, for example, Shelly is the patient, or Shelly is the person who wants to have either the health record data or the medical record data. So my data will not be fragmented, and I'll be able to have my data at a single place into a form of a health record, and that is referred to as an electronic health record. And if I am a patient, then my same thing will be called as an electronic medical record. So the difference between the health record and a medical record is the health record is a lifelong record of a person, right? So even if I'm into a well stage, starting from, for example, you might have seen into a iPhone, there's an app called as a health, right? So that particular app is doing what? Your daily, it is tracking your daily steps, it is tracking your daily food habits, it is tracking your, if you give the consensus to that particular track to keep a record, then only that particular health app will keep a record, and then it will observe your sleeping pattern, right? So all these kind of things are usually being saved onto that particular app, and that usually gives you, based on that, the week patterns, it usually suggests also, okay, so this is, and then you should go for a walk, or you need to consult, and or this might be, and you can even say, okay, my BP was this at this particular day, and then after a week it was this, and then this was this. So this is what I'm maintaining as a health record of a data, right? So it's not, I'm not ill, I'm not something like that, but I'm recording my data on for just for maintaining my health. So that is what I'm calling as an electronic health record data. And when I become ill at times and I used to visit a hospital, so it means that medically I'm a little bit unfit, and that is why I require some particular test and that I have to go. So that is why my data is considered as an electronic medical record data. So it lacks context, right? So these are some of the disadvantages of the traditional healthcare system. Now, where should I place my blockchain enabled system? So this is just an evolution, just to show you, okay, we started with the first generation where we were just relying on the hard copy. We moved on to the second generation where I refer to them as the digital record, and I used to call it as an electronic health record, right? And then with the third generation, so this is just my classification. Don't consider it otherwise. Like I just decided, okay, the hard copy can be placed as the first generation, the electronic health records can be placed as the second generation, and then with the accumulation of the entrance of the cloud, I have the cloud-based health information systems which are being developed, and I place them into the third generation. And then later on, what was being seen into the healthcare sector was the blockchain-based health information systems. So I thought, okay, after the cloud, this involvement has been done. So let us put this into a fourth generation health information systems. So now the advantages, whatsoever were the disadvantages that we have encountered into the third generation, in order to cater to that privacy, interoperability, security, and integrity issues, the blockchain came into existence and it says, okay, I'll cater to your privacy, I'll cater to your security, and I'll have an integrity of the records also. Also, it's not there that the health information systems that are working into a second generation or a third generation are not providing privacy. We can anonymize the data and then we can release the data for that particular research purpose or something, right? But that usually can be there, but there are still your data is on breach. So that is why the blockchain ensures and says, okay, I'll be able to provide you a privacy, I'll be able to provide you a security. But it still says, while reading the papers from the healthcare sector onto the blockchain, what I found was that interoperability is still an issue. And how the interoperability is an issue is that, for example, the Fortis and the Max are not able to interoperate, but different branches of Max at least are able to interoperate among themselves, right? So still the interoperability was an issue, and then they were not conforming to any of the standard, right? So there are various standards. For example, HIPAA compliance is one of the standard for the security, for the privacy and the security related standard in the healthcare. So currently, whatsoever the health information systems have been developed, they are not following, to the best of my knowledge, they are not following the HIPAA compliances, and they are very complex to implement as on date. So even if we started with doing a very small BTech project with my students, where we started, okay, let us start with an Ethereum one and let us try to save some particular medical records data onto that particular blockchain. The first thing we encountered was the off-chain and the on-chain storage. We were not able to save everything onto the transaction, onto that particular block, and then the size of the blockchain was becoming heavy. So we thought of, okay, then we referred to some papers related to how we can have a amalgamation of an off-chain and an on-chain storage. And then it was not compliant to a HIPAA compliance. So we were looking for how can we have a data which is compliant to some particular standard, and then we can save it onto the blockchain. So what you might be able to see that this is just a statistics of the 2018 data, and might have increased as of now on date by 2022. So it says that the death in the John Hopkins University's researchers have claimed that the death in the US is this is the third factor. The medical error is the third factor, right? So by moving towards the blockchain, I guess the medical error might be reduced. So most of the deaths, if you see on the number 1, number 2, and this is number 3. So this is just researchers have shown in 2018 that this is the yearly death rate as per the John Hopkins University research they have done. So this is the ill-informed clinical decision making. Now, what are the challenges? Can we rely on the data collected by the patients themselves? Is it that we can rely on that the patient collected the data by themselves, and can we rely on that? Right. For example, I have collected my data into an health app, and then I give that particular data to a doctor or something, and then I say, okay, this is my data I've collected by myself on a daily basis or on a monthly basis, and then maybe you can consider this as my history, right? Patient history. So then who should be legally liable for a misdiagnosis or a delayed diagnosis, right? Then unauthorized access and attempts from inside the ecosystem can also be there. Then how to ensure the privacy and the integrity of the data. So these were some of the challenges that were encountered into the healthcare sector. So in order to have an answer to all these challenges, what it says is that first of all, let us make a move towards the electronic health record, medical record, or an health information system. Okay, so PHR stands for personal health record, EHR stands for electronic health record. We had something as a cloud. We compliant to the HIPAA compliance, and then we saved it into in form of an EMR. We have a healthcare provider A, we have a healthcare provider B. So this is HIPAA compliant electronic medical record is saved at the healthcare provider B, and this HIPAA compliant electronic medical record is being saved at this one. So this is just a conceptual cloud-based EHR EMR system or a PHR ecosystem that is there. Now, this is another blockchain-based solution to it. Okay, so that was just a cloud-based solution. So this is just a conceptual blockchain-based EHR EMR or a PHR ecosystem, where it says that the healthcare provider wants to add a new medical record to the patient to the patient EHR. right? So a block containing the timestamp, medical information, and an author is being created, right? So healthcare is the user, the one who had created this particular block. Then the block is delivered to all the peers, and who will be the peers? For example, that related to that particular person is the person himself, then his family members, and the general practitioners, that those who are examining it, right? So then this particular thing is being shared with those stakeholders who are being involved, right? And then this block is then verified and approved, and after the approval, then this particular block is being added onto the blockchain, and it is being linking to the previous one. Okay, so this is just a conceptual blockchain-based EHR, EMR, PHR ecosystem that has been suggested by this particular paper, right? That is in IEEE Cloud Computing. That it says that it's a panacea for a cloud-based data security and privacy. So this is just to show a comparison between a traditional healthcare-based system where, so based on some particular parameters, we just compared the traditional healthcare with the blockchain-based healthcare. So the first parameter was the confidentiality. So in a confidentiality, in this one, end-to-end encryption is provided to the transmitted data. And here, almost the same level of confidentiality is retained if we are moving towards the blockchain enabled. Then immutability is there, right? So databases are at times vulnerable to malicious manipulation. Okay, but so then what we have to do is, in order to cater to that, we have to look for the log, and then we have to see in the log at what particular time, what particular date, but the logs are so much, right? So databases at times are vulnerable to malicious manipulation. And once block is added, it is computationally infeasible to mutate, right? You cannot mutate it. So this particular property provides the advantage. Then traceability is there. So information may alter, which hampers the traceability. But when we are moving towards the blockchain, transactions are traceable to their provenance, guarantees immutability. Okay, so availability, the backups must be managed manually to tackle the failure, right? But here, all nodes having the exact copy of the blockchain with provides high fault tolerance. But it says that you have the exact copy of the blockchain. For example, then now you should know about what is the particular thing or a prerequisite in order to maintain this high fault tolerance. I should have the internet speed very good, right? Because what I'm saying is I should have the same exact copy of the blockchain. For example, a new block is being appended to that particular blockchain, right? And if my internet was not updated, and all the other peers, those who were participating onto the blockchain, had their internet speeds very high. So this is what the thing is, which we have to see from our particular end. So assuming this particular thing, I can assure, okay, I'm having a high fault tolerance. Then the next is the privacy. So data is transmitted in encrypted form, which can be traced back to the data owner in the traditional one. And in privacy, it says that anonymous references. So it will never be revealed onto the blockchain that this particular data belongs to, but I have the key. So I know that this particular transactional data belongs to me, right? But the other person, those who are participating in the blockchain, have anonymous references, right? That protect the privacy and discard any possibility of association. So I can never even relate, for example, if I'm having a diabetes and this, and then there are chances of getting this particular Y disease. So no inference kind of a thing happens when I'm having this blockchain kind of enabled information system. Then speed is there. So transactions are mainly, for example, in the database, we were having one particular data where we were having, for example, the Sam is there, the age is 40. So I added the name, but I kept the age. So I know that Sam is my neighbor and Sam is around 40 years of age. So Sam is suffering from some confidential disease which he don't want to disclose. For example, AIDS or HIV or something like that, which you don't want to disclose. And that particular, so I was trying to find out, the data was being released for the research purpose, but there the anonymous references are there. So anonymous references is usually safeguarding the data. Then the speed is, the transactions are mainly depending on the network transfer rate, and here there are negligible delay is occurring due to the validation of the block. But I'll talk more regarding the speed when I'll be coming later at the research challenges, right? So right now I have just compared and showed, okay, there's the negligible delay because of the validation of the block, but that requires some prerequisites to be met. So whenever I'm moving on to a blockchain, I'm having some certain prerequisites and I'm saying, for example, internet is one, right? And similarly for a miner, the other one is he should have a very powerful machine in order to mine the data, right? So then similarly, there are other prerequisites also, which I'm assuming, and assuming that I'm talking in terms of, okay, the speed has a negligible delay occur. Okay. So now this is the blockchain for securing the healthcare network. So this is just from Sustainable Cities and Society. I had this particular diagram where we made, where it says that, okay, IoT was also being involved and the blockchain concept was being involved, and that is how the patient enabled and blockchain inculcating with IoT system was being developed. Now this is another example. Okay, so this is where I was talking about the government sector also is nowadays making use of a blockchain. Okay, so just have a glance and see what happens is. Okay, so the first, if you see into the step is, this is an election administrator. Okay, and these are the particular people, those who are voting against, and this is the particular administrator. And then this is our blockchain, right, which is containing the blocks, and these are tamper proof. So what happens is, the first one is the election creation. The election creation involves what? The administrator, this particular administrator will create, specifies the election type, right? Then it sets the election policies and it defines the candidate list and it decides the election lifetime. Okay. So this particular administrator, the one who created the election, is the one who had specified the election type, who had set the election policies, who had defined the candidates list, and who had decided the election lifetime. So this is the first one that the particular election administrator as a user has done. The next one is the voter registration. Okay, so this particular user is another one, voter. Now he'll register. So now this particular administrator will authenticate and will authorize, right? And then the voter is assigned with a secure digital key. So this particular voter is assigned with a different secure digital key, and this voter is being assigned with this different secure digital key. Now the third is the vote transaction, right? So this vote transaction covers what? It says that the voter signed the vote using a digital key. So voter signed the vote using the digital key, and there are smart contracts also. Now what this particular smart contracts are doing is, they are checking whether the voter is eligible and the particular person has not voted before, and there is a time span, right? So the voter has casted his or her vote into that particular time span, right? So then so now the vote transaction has finished, and then the next one is vote telling, right? So this is done by the election smart contract, right? So then the smart contract and the vote transaction will make an entry also into this one. Okay, so this is what has happened, and then the last one is a vote verification. So vote verification does what? The voter receives the ID of the vote data and voter verifies the validation of the election. So this is how a blockchain enabled system has these particular transactions saved onto the blockchain, and this is the voter receives the ID of the vote data and voter verifies the validity of the election. So this is how you have a transparent and tamper proof, right, system. When if you are moving from, so nobody can change whatsoever vote you have casted, right? And every voter that was involved into this particular, each voter that was involved into the process had a very secure digital key, right? So this is what is there. Now another example is a smart citizen example, where we had an example of a personal data storage, the personal data access control, and the personal data exchange. Okay. So any questions to anyone till this particular point? Can I tell the participants to turn on the camera? Can I have a glance at them?
Yes, participants, please switch on your cameras.
Sakshi, you can take a snapshot or something also for your records, at least
Yes,
if everybody was
yes,
turning
ma'am.
on the camera. have some water and we can start on.
Participants, please switch on your camera so that we can capture the movement with the speaker.
I hope it's not boring in the early morning. You might not be feeling sleepy.
No, ma'am. It was very interesting and engaging talk by you. Okay, thank you. I have captured the moment.
Okay, Sakshi, I'll continue. Thank you so much for turning on your cameras. Any questions to anyone? Any doubts to anyone? Anyone would like to ask anything? Okay, after the talk here. Okay, fine. I'll move on.
Yeah. Okay. So,
okay, so I went on to the smart citizen. So the smart citizen is, we have the personal data storage, we have the personal data access control, and we have the personal data exchange where if we are moving on from simple citizen towards the smart citizen. Okay, so this is the finance. I hope you'll be enjoying it. You might have learned through the 5 days FTP also. This is the traditional. I'm again coming to the same example, but I'll show you how it varies. Okay, so this is what the concept of the Bitcoin was, right? So whatsoever application during the supply chain I was talking about is not a cryptocurrency application. But now, while I'm talking about a finance sector, I'm talking about a cryptocurrency application. So what is a Bitcoin is? A Bitcoin is, we moved on from the physical asset, right? We have rupees, dollars, yen, and everything was there, and we had a physical asset, right? And they are used for selling, used for purchasing, and they have the transfer of value. Now, what is this Bitcoin? This Bitcoin is a digital asset, right? So that's an electronically transferable over the internet, and asset is it's a valuable entity like gold, a house, or a car. So this is also used for selling, used for purchasing, and for transfer of value. But not required the paper bills, not required the physical currency when you are moving to a Bitcoin. So this is what the concept of the Bitcoin is. So this is simply trying to show you that there were intermediaries where if you want to do the value, so you can have either a PayPal or a credit card kind of a system. And here the Bitcoin concept is there, right? So in the Bitcoin concept, you don't require any intermediaries to be there, right? You can directly transfer from the sender towards the receiver. So the particular correspondent bank is being removed when from the sender and the receiver, and you have a Bitcoin network in between. So everybody is able to see whatever the transactions are being done, and everybody is able to transact corresponding to it. So initially the Bitcoin says, okay, this much amount of everybody, the initial amount is being declared, and then everybody can transact corresponding to that. So this is where the example of a bank is. So for example, this is what usually was happening. For the account and the identity management, there were links, personal information to the bank account and verifies the ownership. Okay, so this is how the account and identity management is usually being done into a bank. Then how the service is, you transfer and you redeem the money. These are the services being provided by the bank. For record management, we update and track the account balance. And for trust, we provide security by professionals under the regulations of the government. For example, RBI has given us some certain regulations, and the banks usually operate as per to that. Now see how the scenario has changed. While I'm moving on to a Bitcoin, what it says that the account and identity management is there or not? It says, but linking the personal information to the bank account and verifies the ownership is not there. Autonomously created identities are there, which are given to the users. So this is how the account and the identity management is being done. Then for the services one, the transfer and the redeems money is, you can send the funds between the peers directly, right? So this is the service one. Then for record management, update and tracks the account balance, updates every node, which keeps its own ledger. So distributed ledger is there, and that particular ledger, everybody has a copy of that ledger, and that is updated on every particular node, right? Then for the trust, it says it provides a trusted protocol. So you are relying on some trusted protocols, whereas this says it provides the services by the professionals under the regulations of the government. So then is another example where we were talking about a land registry. So this is a bag of money. You are purchasing a house, right? And then you had some particular deed and you finally did some went to some government office, आपने registry करा ली और finally आपको लगा कि वो घर आपके नाम पे हो गया, ठीक है? But आप देखिए कि क्या हुआ, some malicious thing is there in between, right? और क्या हुआ, वो घर आपके नाम होते हुए भी आपके पास नहीं हुआ है, राइट? बट ब्लॉकचेन सेज, क्योंकि ट्रेडिशनल लेजर था, किसी ने लेजर में कुछ भी कर दिया, चेंजेस कर दिए, कुछ भी कर दिया, बट अल्टीमेटली आपका घर आपके नाम पे नहीं हुआ. And this is what we are encountering a daily, day-to-day basis. Also, we have seen and heard of many cases into the news, as well as we have seen into real life also, that ऐसा हुआ कि the same thing was being sold by one person to different people, and then the particular land was not belonging to you, whereas you were into an impression that that particular land or a house was belonging to you. So this is the concept of the blockchain that was being introduced, and the blockchain says that जो भी आपका malicious है उसको आपने हटाया और consensus के basis पे आगे आपकी nodes हुई, तो that is a transparent, and you can see, okay, this particular house is having this particular things. If you trace, then you will be able to find it out that, okay, this is where you can go or you can take a risk or not. Then this is the, just to show you that how it is a immutable ledger, right? So the source has been specified. Now this is an example where I talked about a non-cryptocurrency application. For example, I talked about the supply chain management, and I gave an example also related to that. So it says that it has an advantage of a transparency and a security. It reduces the paperwork and the time delays, and it checks for the authenticity and the traceability also. So this is one of the example where it shows that, okay, what has happened when the blockchain for the supply chain or the logistic industry has taken place. So I'll further move on. These are some of the challenges, because I have to talk about the research issues and the open issues that are there. So you can just have a glance at it. So what are the challenges? The suppliers or the manufacturer's privacy was one of the challenge, and then the cost of the integration and adoption was another challenge. Now this is in agriculture. So there are some papers and there are some things that are going towards the agricultural, but it's very difficult to implement being at this particular initial phase. But gradually and slowly, I guess we'll be moving towards, and blockchain will be able to provide such advantages to this particular sector also. I'll talk about what are the challenges and why is it a little bit difficult in the agricultural domain. Is it has an advantage that it provides a uniformity, it provides transparency, and it has the global access to the small scale farmers. I'll show you an example in the next one also. For example, this is the farmer, okay, and this is the accessor. Okay, so what the farmer has done is, farmer has evaluated from this particular assessor, and some food quality he wants to get it done from this particular assessor, and this particular assessor has given a certificate. Okay, the food quality for your particular food that you have produced is okay, fine, and then this particular assessor provided a certification, and that has been transmitted to all the peers that were taking part onto this particular network. So this certification information is broadcasted to all the participants that were onto the blockchain. And after more than 50% of the people on the blockchain have given their consensus, then only that block will be verified and will be appended. Otherwise, it will be an unverified block, right? So this is upon the network consensus algorithm. The block transactions are verified based on this one. Then only this particular block will be verified. Otherwise, this block will not be verified. And then only the farmer will be able to sell his produce backed by the immutability property of the blockchain. So this is how the blockchain connected the agricultural sector also. Now, what are the challenges is that most of the farmers are not technologically, so that is one of the hurdles. So that is why I was talking about it is gradually moving towards, and it's very difficult to convince the farmers, right? So those people are okay, they have some intermediaries, they usually sell it to intermediaries usually sell it to us on a higher rate. So intermediaries are the one who are like earning the benefit, and the farmers are the one, those who are not earning the benefit directly, what they should have earned in the amount of the hard work they have done. but still it's very difficult to convince those farmers, and implementing this into an agricultural domain will involve a higher cost also. So then moving on to the power industry. So power industry has, it's lowering the transaction cost. It has the advantage, it gets rid of the third party. It provides and security and transparency. If we move on from blockchain towards this one, then buyers becoming prosumers. Okay, so this is what, for example, you can see, okay, we have the small scale prosumers, but the prosumers can be, the consumers can also be the consumers. So the blockchain technology, prosumers can buy energy as well as they can sell excess available energy also. And then the primary energy source is here, right? So the primary energy source is there, and this is onto a peer-to-peer network, right? And then the making use of the industrial IoT and other things. So then we may have a smart home prosumer also, and we have a smart vehicle prosumer also. So this peer-to-peer transaction of the abundant energy, which was being gained from the primary energy source without any third-party involvement, can be transmitted to the home prosumer as well as to the smart vehicle prosumer, as well as they can also be a consumer also. So the third party is basically eliminated in this particular part, and direct interaction between the source where it was being generated and the person who is being consuming. But it still has the challenges that it has high energy consumption, and scalability is still an issue if we want to move on to the power industry and the blockchain. So then the blockchain-based smart cities are also enabled, and the papers are emphasizing upon the smart citizen, the smart home, smart transportation, smart grid, smart government, and smart education. So this is how there are several funded projects, even by the DST also, which are trying to implement this blockchain-based smart cities, and how they're trying to implement is through implementing the concept of a smart citizen, the smart home, smart transportation, smart grid, smart government, and smart education. So then smart data management is the blueprint for the smart cities. Okay, so moving on to the data management, if you see, this is just data from the Teradata. So this is picked up from the white paper from the Teradata, which says that, okay, you have the smart city data, and that data is about what? Toll and express lane, asset management, transportation plans, transit, freight, connected vehicles, CCTVs data. Then you have dynamic message signs, you have traffic and environmental sensors, non-traditional data sources, pedestrian. So considering that this is the smart city data, then multiple transportation data sources are there, non-traditional data sources are there, right? And then here are the smart city applications. So advanced analytics and the analytics exchange is being required, plus integrated data exchange is being required. So when we are talking about a smart city, right now we are moving towards, but the thing is that we are generated with the ample amount of data that is usually high in volume, that is changing in velocity, and that has the veracity concept also. So what should we do? So it says that one of the research challenges, how should you manage that particular data, right? So smart data management that is why I refer to as the blueprint of the smart cities. That is why this particular title has been given. So now what the research question is that, can we leverage the blockchain by making use of this particular whatsoever the data management field has the advances in that, can we leverage the blockchain field, okay, by making use of whatsoever leveraging or the research has been done into the data management field. So these are some of the blockchain development tools that can be used: interdisciplinary IPFS and Remix ID, Gate, Parity, Ganache, or MetaMask. So any of the tools can be used. Then these are the research challenges. Okay, so the scalability, privacy, security, energy consumption, although on the one way we are saying we are trying to have a privacy as an advantage and the security is there, but the thing is that there are still research challenges. So the first, while we are talking about scalability, how to make the blockchain scalable in terms of joining nodes. The second challenge is how to make the blockchain scalable in terms of transactions per second, right? So usually when we draw the graph and we write a paper and we do some experiment, we usually draw it and show the throughput, right? And then we show the scalability as a factor, and then we show, okay, this is the existing one being scalable in this particular terms, and this is how we are providing a new, for example, a chain by the name of, for example, in a healthcare or in any other domain. So this is how we can usually measure it. Then in terms of a privacy, the research challenge is how to preserve the information privacy when multiple entities are part of the blockchain system, right? So this is another question. Then regarding the security, so there was a something into a newspaper also that the blockchain was being susceptible to a vulnerability that was called as a 51% attack, and then there are some certain vulnerabilities to the blockchain also. So how to make the blockchain secure from these vulnerabilities, such as the message hijack, 51% attack, Goldfinger attack, and others. Then energy consumption, how to check the energy consumption in various domains is another point of concern. Then the cost and the awareness, how to make a blockchain enabled system cost effective. Most of the times, if we are talking about, is usually like we have to spend, if in case, for example, in a mining, you really have to spend much amount of a cost. And then how to motivate the people to use them, because people are not being aware. So I had already shown you an example where we talked about the Bitcoin, the Neo coin. That is very similar to a cryptocurrency used by the big basket, and then the smitten bucks that is being used by another application called as the smitten. Okay, so then the blockchain interoperability. So how to facilitate the transfer of the information against multiple chains. So this blockchain interoperability, very less amount of work is being done on this particular research field. And then how to facilitate the transfer of information among the multiple chains is an emerging area, and the one who is providing an algorithm or doing some research and sending that particular paper, the chances are very, very high of getting this thing published. Right. Then this is where I was talking about that when we have the data management capability, right? So can we leverage that particular field, right, with the blockchain? So, for example, in the when I'm talking about the databases, I'm talking about moving towards the big data, and what I'm having is that the data stores are there where I'm making a move towards from the SQL systems, that is the relational databases, towards the NoSQL systems, NoSQL systems. So what it says is that novel techniques are needed for supporting the multiple types of data stores. We are there with the key value store, we are there with the document stores, we have the SQL, and we also have the special data stores simultaneously in the same blockchain system. So if we have such kind of data stores onto the same blockchain system, then we need support for these multiple types of data stores, right? So that is an emerging area that multi-storage and indexing support is being required. For example, the Ethereum adopt the key value data model, the R3 Corda uses the relational data model, and Hyperledger Fabric says that you can opt for a pluggable storage model. It can either be a level DB key value store, or you can have a couch DB for a document store. Then the next research area to work on is to develop the blockchain systems with inbuilt offline storage strategies for handling the big data. So we have the digital documents infeasible to store due to several constraints because of the storage size, the bandwidth, and the transaction throughput. So we really need to have an architecture where we are talking about an amalgamation of the online storage with the offline storages. So that requires, but then again we have the thing that, okay, how to link, and while during linking of that particular from the on-chain storage towards the off-chain storage, are there some security or privacy issues, or would our blockchain be able to cater to that? Then is the master data management. Under the master data management is the organizations need master data management rules, processes, and techniques in order to consolidate the data from the multiple blockchain networks. For example, so if we are talking about an organization, it may be having a blockchain 1 for a different purpose, it may be having a blockchain 2 from a different purpose, and it may be having a blockchain for a different purpose, blockchain 3. For example, for a supply chain management, it has a different one. For keeping the employees' data, it has a different blockchain. And then for a different the production line may have a different blockchain, right? So that is why then master data management rules are being needed in order to consolidate the data that are being saved onto the multiple blockchain networks. Then as we are aware of, that databases have the ACID properties, right? So can we develop the novel concurrency control models for the blockchains? so that they are applicable to a wider range of an applications. So that is another area where we can work on. Then scalable transaction throughput I've already told you, and there's one thing called as a big chain DB. So there's a very good paper on a big chain DB where they have proposed a database, blockchain database, in which they are talking about, okay, this is what the properties of the database was, this is what the properties of the blockchain was, and then they try to say that, okay, query in terms of querying, in terms of indexing. Now this big chain DB has been proposed, and big chain DB is able to cater to whatsoever advantages of the blockchain were and whatsoever advantages of the databases were. So then this paper has, this big chain DB research has proved that, okay, we have some certain advantages from this field. So that is how the people are working on, because that particular database has started on into 1970s. So from 1970s till date, many research papers and many ideas have been floated by various researchers, and we can say, okay, the research has reached to a stage where you can say, okay, we can simply use it, considering it as a benchmark, or we can say we can use it. These things we cannot even cross question, considering the research from the 1970s till particular date, right? But blockchain is an emerging area, so still the things are going on, so people are really reluctant to move on, whether to use and whether not to use, right? Whether to spend this much amount on moving from the traditional things towards the blockchain, or whether to retain on to the previous one. So energy efficiency is the one, incentive mechanism is the one, smart contract management is another one, and the regulation. So these are, this is what I talked about. Is it possible to utilize the existing capabilities of a mature data and information systems through robust integration onto the blockchains? So this is where the problem was. And then there are some research directions where I'm working along with my PhD scholars and my BTech students, where we are trying to just create a framework so that it can be used to curb the novel coronavirus disease. So what we found that during the coronavirus, what happened was that there was lack of beds, and then there was some particular injection and tablets that were being black marketed like anything. Even the oxygen cylinders were being black marketed like anything. So we thought of, why can't we keep a track or a record onto the blockchain where we have a very like a transparency kind of a system. Okay, this hospital is having these many cylinders taken, this hospital is having these many number of injections, and then whenever a next pandemic situation may occur, at least a blockchain will be able to simplify and give a transparency to the users, despite of at that particular person, at that particular time, people were even paying 50,000 rupees or something like even 90,000 for simple an injection, which was costing just around 600 or so, right? So how the blockchain framework can be used to curb the novel coronavirus disease or can cater to a pandemic. To solve the problem of the interoperability in the end-to-end healthcare domain. So this is another domain where we are working on. So I told you that interoperability is still, so we are trying to propose a architecture where we are making a healthcare system compliant to some particular standard, interoperable standard, semantic interoperable standard, and then we are trying to solve the problem of interoperability. And then the next one is to provide a better and accurate information to the patients in the real time. So we just created a health information system. We had given that name, some name to that particular system, and that one of our paper is under the review related to where we had created a system related to this particular blockchain, and we had a health information system that is taking care of the patients in the real time and providing some advantages that blockchain is offering us. Now, these are some limitations of the blockchain. So the Bitcoin proof of work is computationally difficult to break, but not impossible. So attackers can deploy high power servers to do more work than the total work on the blockchain, right? So this is one of the, in November 2013, a known case of successful double spending was there, and it was gathered that ghash.io mining pool appeared to be engaging in repeated payment fraud against the BET coin dice, gambling. So this is the source to it. So this is the particular case. And then the monopoly problem is there. So proof of work depends on the computing resources available to the miners, and miners having more resources have more probability to compete the work. So this can be there now. So with this, I would like to conclude my slide. So what we learned for today's slide is we learned about the blockchain. So I just had made a revision of what you learned during the 5 days. We moved on to the features of the blockchain and how these features can be helpful in the marketplaces. We talked about various application scenarios from e-voting to smart from e-voting to the pay as per you go, car micro insurance, the supply chain example. And then we had talked about some certain open issues and we had the certain research directions. So with this, I would like to conclude my talk. I had some references also. So now if somebody has some particular questions, can ask me.
Any queries from the audience? I guess, ma'am, no. You have already delivered a very insightful and informative session. So thank you so much, ma'am, for sharing your knowledge with us.
Yeah, I guess Abhishek Saxena wants to say something.
Yes, ma'am. You've said that interoperability is a challenge in the current scenario of the blockchain, and we are working and we are having certain things that we need to do to maintain a proper interoperability in the blockchain concept. So the algorithms that we are having, for example, the consensus or any other algorithms, they're not giving fruitful results or they are lacking the features so that we need more secure blockchain.
No, the problem doesn't lies in the algorithm or something. The problem lies in that all the particular stakeholders that has to be involved has to move towards the blockchain. For example, the Fortis hospital has to provide the consensus rules or the smart contracts that needs to be filled up over there. The Max has to interoperate with that one. The Max, the Fortis, and all these big hospitals or the chains need to be the stakeholders onto the blockchain so that the rules should be written onto the smart contracts like that one. So here is where the problem is when we are talking about an interoperability. For example, Max says, okay, even if I want to move on, I can have a blockchain based network with my own branches of the Max at other places. So here is the problem. The problem is not there in that particular thing, but the problem is at this particular place.
Okay. Thank you.
Okay, thank you so much to all the participants also, and thanks for the organizing team.
Thank you, ma'am.
Thank you.
Thank you for such a wonderful talk.
Thank you, madam.
Thank you, ma'am. We can have a photograph, Sakshi, once again.
Yes,
and
ma'am.
Adarsh sir is also here. May I request Adarsh sir and other participants, please switch on your cameras so that we can capture the moments.
Hello, Dr. Adarsh.
Hello, Adarsh sir. Good morning.
Good morning, sir.
आप म्यूट पे हो डॉक्टर आदर्श.
Sir, your voice is.
Right. Hello, everyone.
Hello, sir.
Long time to see you all. Nice to meet you. Nice to meet you all.
Yes, ma'am. Kavita, ma'am, I have captured the moment.
Okay, thank you, ma'am.
Okay, thank you so much. Okay, I'm leaving. Okay, thanks. Bye.
Thank you, madam. Good morning, Adarsh sir.
Good morning, sir. Welcome.
Good morning, Dr. Raghu. How are you?
Fine, sir.
Can I share my screen?
Yeah. Yes, sir.
Right.